about it is fundamentally consistent with Tesla's notion about the undulatory waveform characteristics and harmonic resonance that operate to make nature work. And that's reflected in his work. Nobody knows it's there. All this wonderful information is available, and it solves a whole bunch of problems in the underpinnings. So one of the things we can do when we get rolling along in A.E.R.O. and pulling together to make things happen is to make sure this stuff gets published and gets circulated. At least to get it on the website in a PDF so people can get it. Because it's spectacular. It's really wonderful work. We talk about some of the things in the model. We talk about the source charge problem. We talk about energy generation dynamics. And one of the things that nobody explains is, I mean, you're driving electric power, you're driving electric power, you're driving electric power, but at the core, where does that energy come from? When you get to the primary scale, there's nothing in the theoretical underpinnings that says, well, where the hell does it come from? The source charge problem. It's the most difficult problem in scalar physics. Number one, when you understand how that works, you really got it going on. We think we've got a grip on it, and that's what we're going to talk about. The laws of physics today say that non-local field effects do not exist. They do not occur naturally. That's the party line. But we know for sure that they do. And there's a whole long list of very interesting, hardcore, rigorously validated and reported scientific experiments which say that not only are there such things as non-local field effects, but they are ubiquitous and they are contemporaneous and complementary to every local linear field effect. Wherever you find one, you must also find the other. You will never find them in isolation except at those formative stages, at the finer scales where complexity is being evolved out of the physical vacuum. And we're going to show you how that works. If I can figure out how to make this work. These are the pieces that are missing from the standard model. Prigogine and Stenger's got the Nobel Prize for their work in dissipative structures. And then people started asking this real hard question. If the whole cosmos is winding down to entropy, how come there's a whole nebulas up there building brand new stars? Like, what's wrong with this picture? Then along comes Per Bach at the Brookhaven National Lab and says, whoa, we've got an experiment, and it just proves the basic fundamental laws, and they operate contemporaneously. Another indication that there probably wasn't a Big Bang. We'll talk about that. There's things that happen in phenomena that have to do with the angularity of interactions. That, except for rare exceptions, which you've mentioned some of today in your presentation, simply have no explanation in physics. Physics doesn't talk about it. Doesn't talk about the angularity of intersections. And it doesn't talk about things like subquarks. But as far as I'm concerned, one of the fundamental things that's wrong with science is this institutional resistance to knowing what's true at the cost of protecting the territorial imperative about what we own. So here's how this works. As far as I'm concerned, the issue of subquarks is the biggest, most egregious, suppression of scientific information in the history of science. And here's how it goes. Gell-Mann, 1986, MIT, gets the Nobel Prize for the discovery, physical verification of 2 of the 6 quarks that he writes about. Nobel Prize. The smallest indivisible particle, right? 5 years later, postdocs, students of his, lead a study at Fermilabs in Chicago. By the time they're done, 7 years later, 450 PhDs, 450 PhDs, called the CDF Fermilabs Collaboration, sign a paper that says they now have categorical verification that quarks can be subdivided into subquarks. They write the paper, They send it to Discover magazine. Discover publishes a notice. It's been peer-reviewed. They're going to publish it. 3 weeks before the publication date, Fermilabs is threatened, and the CDF collaboration members personally are threatened with professional, political, economic extinction unless they withdraw the paper. The lab is notified by the Department of Energy that it will be defunded if they don't withdraw the paper. Even though the paper's 7 years in the making, signed by 450 people, and has been peer-reviewed and approved. So today, the Standard Model says there's nothing finer at any more minute scale than a quark. Why? Because MIT and Murray Gell-Mann and the people in the high-temperature gas-cooled nuclear reactor crowd who have privileged access to the research capital food trough are protecting their territory at the cost of the truth about how science really works and what's really true about how nature works. You see, if there are subquarks, and if they are the way their paper described, it has profound implications for what's true about the way nature works.
Can you just elaborate? Are you quite sure that it was the science community?
It was the science community.
That put that down?
Yes, sir.
Not intelligence.
It was not intelligence. It was not
anything else?
Congress. It was directly as a result of the interdiction of the publishing of that paper by people at MIT, and that's a known fact. It's the same thing that happened with cold fusion for exactly the same reason, by exactly the same people. Nothing new about this story.
They're as bad as the church was.
But it's
300 years
fundamental.
ago.
Well, you know,
in some ways.
The priesthood of science has its own cult. It has its own language. It has its own standards. It has its own jargon. I mean, except for strange underwear and a private handshake, you know, they're pretty interesting. So we're going to talk about things called virtual ensembles. You haven't heard of those before, but we're going to make sense out of them. And then we're going to try to do something that science doesn't do. We're going to try to define mass, not talk about it in terms of its properties, but how it is formed and what it is. And what is magnetism? Not describe it in terms of the phenomenological measurements, but what it is and how it comes to be and how it works. And the same thing with gravitational field effects. These are fundamental to any understanding of how nature works. And science can't tell you. If you go to Wikipedia or any scientific encyclopedia and you look up mass, it'll tell you that mass is the part of matter that demonstrates inertia. That doesn't tell you anything, but that's all they go to. What is magnetism? Magnetism is a property of certain elements in the periodic table that exerts these kinds of field effects. Well, what the hell is it? And how come only 6 materials in the periodic chart exhibit this property? Why don't the rest of them exhibit it? And how does it come to be? And what is it really? And if we don't understand that, how in the world can we understand how to describe what goes on inside the atom? I mean, it's no wonder that the Standard Model can't predict what a muon's going to do in a particle accelerator. They're not even close. They're not even close. So we're going to talk about that. There's some flawed assumptions that make up the Standard Model. One of them is that energy equals mass accelerated at the square of the speed of light. That's Albert's watchword. And it ain't true. And I'm going to make a prediction right now that will tell you why. The Rensselaer Polytechnical Institute just released a notice last Thursday about a brand new material in sheets like paper, about the same thickness. Carbon nanostructures that are solid-state energy storage wells. Okay? Energy accumulator wells. What's going to happen one day is that somebody's going to stack a bunch of those babies together, hook them up in parallel in series, and charge them. And when they measure the mass, they're going to discover